Chapter 3. It is hard to believe how quickly this semester is moving forward, and we're already in Chapter 3. In Chapter 3, we're going to learn about some new tools, different tools than we have had in the past. We're going to talk about percentiles and quartiles. We'll look at exploratory data analysis activities, and that'll be the stem and leaf and in the box plot. We're going to look at how to identify outliers, look at some different means of doing that, and then we're going to look at a geometric mean and a weighted average. Percentiles, in a sequence data set, we are looking to find the number in the data set that will represent the percentage we are looking for. As an example, if in a data set we wanted to look at what the 50th percentile was, we would put 50 over 100, divide by the number of items in the data set, and that would give us the item in the data set that we need to look for. If the calculation that we go through puts us on an integer, add that number and the next number in the data set and divide by 2. That'll be our percentile that we're looking for. If the calculation is not an integer, use the next number in the data set. For example purposes, we're going to use these 72 numbers in the data set. We will practice with these. This identifies the rule that we just talked about. If the calculation is an integer, add that number and the next number in the data set and divide by 2, etc. We're going to look at quartiles. In that same data set, if we want to find we will look to find the 25th, the 50th, and the 75th percentile. Use the same type of process that we used before. Then we're going to go use that data and determine our IQR, our interquartile range. This will be the middle 50% of the numbers in the data set. We take the 75th percentile, subtract it from it the 25th percentile, and that will give us the middle 50% of the data. If we go back and look at that 72 numbers of data set that we looked at previously, we've determined that the third quartile is 753.5, the first quartile is 233.5, the IQR, or the interquartile range, will be 753.5 minus 233.5, or 520. When we look at exploratory data analysis, we're going to look at two types of tools. We're going to look at the stem and leaf and box plot. The stem and leaf will show the shape of the data distribution. The item on the left on this particular column, the 32, 33 through 39, is the stem. The last item, or the number to the right of the solid line, is your leaf. Each individual item in the data set is logged individually. The stem and leaf diagram that will display the rank order and the shape of the distribution of the data. And again, each line in the display is referred to as a stem, and each digit on a stem is referred to as a leaf. The second item is the box plot. This is going to emphasize quartiles and shows central tendency, shows the shape, extreme values in the data set. We're going to use the Q1 and Q3 again that we learned about in the IQR. We're going to use that to establish the size of the box. We need to know the smallest value, the first quartile, the median, the third quartile, and the largest data in that data set for calculation purposes. The lowest value on the data that we looked at, if you back to the 72 data set example from Apex, the lowest value is 13, the largest is 989. In our calculations, we determined that the first quartile was 233.5, the third quartile was 753.5, so we're going to draw a box around that. The median at the 50 percentile was 517. So now we can identify outliers. We're going to start looking at how to do that. An outlier is an exceptionally small or large value in a data set. It might be, maybe you recorded the data incorrectly. Maybe it doesn't belong in the data set. Once an outlier is identified, you can look more closely to determine its cause. So we're going to talk about three types of empirical rules. The first one is that old bell-shaped curve. And we're going to use this particular tool the rest of the semester. When we start talking about standard deviation, if we're within one standard deviation of the mean, we're going to be talking 68.3% of all data values will fall within that. Two standard deviations will be 95.5, and three standard deviations will be 99.7 of all data values. Remember, it has to be a bell-shaped curve for these percentages to be meaningful. Z-score. What is a Z-score? That's a standardized value. It denotes the number of standard deviations a value is from the mean. We've learned previously how to calculate standard deviation. So now to get a Z-score, we're going to take the individual data element value minus the mean divided by the standard deviation. That will give us our Z-score. You can calculate that for every data value. Anything that is a +3 or a -3 on the Z-scores is going to be considered an outlier normally. And we're going to look at covariance just briefly. Covariance, it'll identify positive values and negative values in that type of relationship between the data elements that we're looking at. These formulas can be used to calculate it. However, if we look at a positive covariance, it's going to be an upward slope. A negative variance is going to be a negative slope. If there is no covariance, it's going to be all over the place, like item C on this chart looks like. I like the example that's given in the book on geometric mean. It talks about the beginning value of an economy and the ending value of an economy over time. And maybe we're talking stock values or stock index values. You can put anything that you want to or need to measure in this formula. And then based on the number of years, what's the average growth per year? So it's the ending amount divided by the beginning amount, the number of years in this case, and the square root of that. That becomes your geometric mean. The other area that we're going to look at is weighted average. And again, the example in the book, I think, gives a good example of that. Looking at grades, and we all look at those. If your grade is a C, the points you receive for that, multiplied times the credit hours, give you weighted points. Once you've determined your total weighted points, you divide that by the number of credit hours to give you your weighted average. All of you use this on a regular basis, I'm sure. The formula for that, and it says there's a quiz problem on this, is as shown here. The sum of the weight for the data value, WI, times XI, being the data value of that, divided by WI, gives you your average weight. Back to this, it tells you what those are. XI, in this case, was points for the grade that you received. WI is your credit hours. WX, integer weight divided by XI gives you your weighted average, or your weighted points for each individual grade given. Sum those up. And I guess the word of caution that I would use here, always make sure you're measuring what you're looking for. In this case, you're looking for the weighted average of all grades for the quarter. Make sure you're dividing the right thing by the right thing. Oftentimes, just a sanity check will give you that type of information. That ends a quick introduction to Chapter 3. Like I said at the beginning, it's hard to believe we're at this point already.